So there are actually three main types, or the three most common types, which we'll look at now. So the three main types of radiation, we use the Greek alphabet to show these. There's alpha radiation, there's beta radiation, and there's gamma radiation. They're the first three letters of the Greek alphabet. So let's start with alpha radiation. Sometimes these types of radiation are also called decay, because decay, think about tooth decay, that means breaking down and breaking apart. So alpha decay, in alpha decay, the nucleus releases a pretty big particle. We can see it over here. It's made of 2 protons and 2 neutrons. And this particle is actually called an alpha particle. So this is one of the particle types of radiation. And actually, if we think about it, this alpha particle, this is actually just the nucleus of a helium atom. Because helium, it has the atomic number 2, so it has 2 protons, and it has a mass number of 4, which means it has 2 neutrons as well. So alpha particles are actually just a helium nucleus. So we can think of it as that original atom is splitting up into 2 different atoms. So an alpha particle is the same as a helium nucleus. It's not really a helium atom though, because there are no electrons flying around it. So let's look at an example of alpha decay. In this one, uranium is a common element that shows alpha decay, and in particular uranium-238. So there's 92 protons here, and it's an unstable nucleus. So when it breaks down, it's radioactive, it releases its alpha particle, and because it's lost 2 protons, it's actually changed to become a different element now. And it becomes thorium here. Think of it as we've gone down 2, or we've gone backwards 2 spots in the periodic table. So that element's thorium, and now we've lost 2 neutrons as well. So we've lost a mass of 4. We've gone down to 234. So this final isotope is called thorium-234. Alright, the second common type of radiation is called beta decay. And in beta decay, we're releasing a beta particle. So, surprisingly, they named the decay after the particle, just like before. And beta particles, we've actually seen them before as well. They're just an electron. But these electrons haven't come from out around the normal part of the atom. They've come from the nucleus itself. And what scientists have discovered is that a neutron is actually made up of a proton and an electron joined together. So neutrons are a proton plus an electron. And we can think of it, protons have a positive charge, electrons have a negative, so together, when we join them, they make a neutron with no charge. So in this example, we've got carbon-14, which we've come across before, and it undergoes beta decay. So if we keep waiting long enough, eventually one of those neutrons, it will spontaneously lose an electron, and now that there's no more electron, we've lost a negative charge, so it becomes positively charged. So the neutron becomes a proton. And we've lost our radiation, which is an electron flying off to go and do something else. When we look at the chemical equation for this, we started with carbon-14 and it had 6 protons, but now we know we've gained a proton, and whenever the protons change, we've made a new element. So we've now got nitrogen, which is the 7th element, but we still have the same number of protons plus neutrons, because that's the mass number. So it still weighs 14. So now we had carbon, and that became nitrogen after this decay. Okay, let's keep looking at the types of radiation. So we've already looked at alpha decay, that makes an alpha particle, and we looked at beta decay, that makes a beta particle. The third type, the third most common type of radiation is one that doesn't actually make a particle, it releases energy. And this is called gamma radiation. Sometimes it's called gamma waves or gamma rays as well. So we'll still call it gamma decay, but the type of energy that we're making is a gamma ray. So this type of radioactive decay, it happens when we still have an unstable nucleus again. So whatever this isotope is, here we've got cobalt 60. This nucleus is unstable, but we call it a high energy. Just like, high energy. Just like when you've got a lot of energy and you're jumping around and bouncing off the walls, a nucleus that's got a lot of energy, it's vibrating and moving a lot, and it needs to get rid of that energy somehow. And the way it does that is by giving off a gamma ray. So we've mentioned gamma rays are a type of energy, and actually they're a type of light. And we've actually come across them before when we learnt about light back in the physics topic. So remember, light, it can be just visible light, but remember there are lots of other forms of light depending on the wavelength. We can have infrared light, we can have ultraviolet, X-rays, and we can also have gamma rays. So the proper name for this is electromagnetic radiation. Electromagnetic meaning light, and it's radiation. So these gamma rays, they get released by the high energy nucleus, but because it's just energy, it's not a particle, it doesn't actually weigh anything. So we started with cobalt-60 here, and it hasn't lost any mass, and it hasn't changed any protons or neutrons, so we're staying as the same element in the end. So the element stays the same. Often gamma decay happens at the same time as alpha or beta. So sometimes there is a mass change, but if there's just one gamma ray released, then we're not changing the element here.